When an enterprise launches a pay-per-use or subscription model, it generates millions of raw usage events at the front end. Every one of those events must eventually map to a strict, auditable financial ledger at the back end. The challenge is structural. Customer selections are dynamic. Users upgrade, downgrade, and cancel subscriptions mid-cycle. Financial accounting, however, demands rigid, unchangeable rules for revenue recognition and taxation. SAP addresses this friction point using 4 core engines: subscription order management, convergent charging, convergent invoicing, and FICA. Between the dynamic front end and the strict financial back end lies the integration gap. Bridging that gap requires highly specific mapping. The systems communicate through a deterministic chain of ABAP objects, programming interfaces, and rigid distribution frameworks. We are going to map that entire object chain, tracing the data path from foundational master data anchors through order generation and contract distribution, all the way down to the specific billable items posted in convergent invoicing. This sequence of objects provides the connective tissue needed for a commercial request to resolve into a valid financial posting. 3 foundational master data pillars are required: business partner, contract account, and product. The business partner requires the mandatory MKK role. Tied directly is the contract account, carrying financial execution logic. The final pillar, product, is extended using specific ABAP classes to handle subscription variables. These 3 structures hold the baseline rules for pricing and ledger placement, remaining inactive until triggered. If any master data anchors are misconfigured, downstream creation of a provider contract is completely blocked. Once the master data is set, execution begins with a subscription order, initiated via a transaction type like PRVO. At the header level, transaction category 265 dictates this document is an order. A separate category, 266, is reserved for the contract generated upon release. As the order is entered, the system evaluates SD pricing conditions, primarily condition type PSBB, calculating bundle prices. For customizable products, the user configures technical characteristics like CPU cores through the Advanced Variant Configurator. Cross-catalog mapping translates these front-end UI selections into automated pricing inputs for the back-end rating engine. It binds that specific AVC characteristic from the order directly to a convergent charging parameter. Within this mapping, technical resources link the convergent charging service ID to hardware identifiers, allowing incoming usage records to be tracked against the subscription. This precise mapping acts as the critical technical mechanism, seamlessly translating front-end commercial choices directly into automated back-end rating logic. When released, the subscription order enters the Order Distribution Infrastructure, or ODI. This acts as a technical filter, sorting items based on lifecycle. Short lifetime items, like one-time activation fees, bypass the contract and go directly into convergent invoicing. Long lifetime services pass through to generate the provider contract in both FICA and convergent charging. For items with recurring fees, the ODI ensures a dependent billing plan is established in convergent invoicing, which holds the billing cycle and payment amount. This setup allows the system to process complex B2B and B2C master agreements. This chart shows examples of cross-contract discounting, such as a B2B agreement where total quarterly usage over €200 triggers a 3% discount across multiple contract partners. Convergent invoicing relies on source transaction type disk B to calculate this automatically. It isolates disk B tagged base items, calculating discounts before generating final billing documents. For these master agreement discounts to work, the base item classes must contain the interface component DISC_AGRMT, along with the required calculation fields. By combining the order distribution infrastructure with strict transaction types, the architecture ensures that short-term revenue, recurring fees, and complex scale discounts are all routed to the correct rating engines. Initial contract creation is straightforward. The complexity increases with mid-cycle contract changes. To maintain financial auditability when a customer modifies their service, the system uses the Business Transactions Maintenance Framework, or BTMF. A change process is initiated through standard SOAP APIs, such as CRM_ISX_BTX_API_cont_change. This process generates a transient change order based on the current contract, rather than overwriting existing data. When that change order merges back into the main contract, it creates time slices. The timeline fractures at the moment of change. The previous state is marked technically inactive to preserve history, while the new slice becomes technically active. This temporal split informs convergent invoicing exactly how to prorate fees, billing the old rate up to the split and the new rate immediately after. The BTMF time slice model protects the integrity of the ledger, ensuring mid-cycle configuration changes do not create orphan prorations or break historical auditability. Pulling back, it reveals the entire connected ABAP object chain. This architecture provides a deterministic bridge between commercial intent and financial execution. Every contract remains anchored to the mandatory master data of the business partner and the contract account. Cross-catalog mapping translates custom order configurations into readable rating parameters, while the BTMF time slice model manages pricing mutations without corrupting the financial ledger. The BRIM architecture functions as an orchestrated sequence of discrete ABAP APIs and time-bound contract objects. Mastering this highly specific architectural chain allows developers to execute high-volume enterprise monetization accurately and at massive scale.